There are only two types of energy that we're going to consider in this physics course: potential and kinetic. Potential is written as the capital letter U, and kinetic energy is written as the capital letter K. So since these are the only two types of energy that we're going to consider, then the total energy has to be the potential energy of an object plus the kinetic energy of an object. And we can write that as the summation of energy is equal to total potential energy plus total kinetic energy. Now we're going to relate energy to the concept of work. And what is work, really? Well, work is anything that causes a change in the total energy of a system. So work can be written as the change in, which is delta, of E, which is energy. And this is pretty much what the work energy principle is. So the work energy principle basically states that if work is done on a system, the total amount of energy would change. An example of this in action would be a block sliding across a rough surface. Let's say at the beginning it has some positive velocity and it's just moving across, and the frictional forces from this rough surface are working against the block to eventually slow it down and bring it to a stop. So in the beginning it has some kinetic energy because it's moving, but at the end we can say that it has no energy left because it's not moving. So the frictional forces from the rough surface did negative work on this block to get it to stop moving. And why is the work negative? Well, remember, if work is done on the system, then the total amount of energy would change according to the work energy principle. Mathematically, we can write that as the initial energy of a system plus any work done on it equals the final energy of the system. And since the final energy of the system, in this case, is 0, then we have initial plus work is equal to 0. And if we subtract work from both sides of the equation, we get that initial energy is equal to negative work. So that means that the work done is negative the quantity of energy that we had at the beginning. There is a catch to this though. Notice how the frictional force working on the block is parallel to the block's motion. So the frictional force was acting this way, so it was in the opposite direction, but it was parallel to the direction of the block's motion. And because it was parallel, it was able to do work on the block. So work is parallel. That means for an object in circular motion does not experience any work by the centripetal force, because the centripetal force always points to the center, and the object's velocity is going in a direction that's tangential to the circle. That means the angle between these two vectors is going to be a right angle, or 90 degrees. And because of this, because they are perpendicular to each other, the centripetal force does no work on the object that's moving around in a circle, because work must be done in a direction that's parallel to the object's motion.